Hi everyone, uh, this is Dhruv. Let's start. And I'm sure by the time we welcome everyone, there will be more people joining in. So, welcome to the second session of the PC working group. Uh, Julian and I are uh, not on site, and we have Hari taking care of on site if there is any need that arises. This is our note well, and by participating in this IETF meeting, both online as well as on site, you are agreeing to the IETF process and policies. All your contribution, the things that you do on chat or on the mic, are contributions to the IETF, and our other IETF IPR rules are applicable. So please take care of that. You are also agreeing to working in a constructive environment. So take care of the anti-harassment policies and other rules of code of conduct in the ITF. So please go through all these important documents which describe the ITF process and rules that we live by. So kindly note it well. Now, I think you must be getting familiar with participation both for in-person as well as remote. Please make sure to join the Meet Echo queue for in-person participants as well, that we will be calling the queue based on Meet Echo and not person standing on the mic. So we will have a common queue on Meet Echo. Please follow that. And kindly take care of your audio and video. Please do not send without joining the queue, and make sure to respect like the AV rules that we have. With respect to ITF guidelines and conduct, we must extend respect and courtesy to all our colleagues at all times. Sometimes we have impersonal discussions, but the aim is always to contribute to the global internet that meets diverse needs of various different technical and operational environment. So please go through BCPE 54 and follow these ITF guidelines and code of conduct, both on site as well as on our mic lines as well as Jabber and chat. Finally, administrative here, we have Hari who has been helping us. So our minutes are sorted by Hari. I will post the link for the collaborative minutes. So please, anybody who can help, please help. I've done that as well. Uh, as I was mentioning, please use the Meetecho etiquette, join the queue, be mindful of the agenda time, though we have enough time for discussions between talks, so please use them. Let's have a good discussion on today's agenda. This is our part two of our agenda. The only change that was requested was a swap of order in our first two presentations as per authors. So we have done that. Otherwise, the agenda is the same. And we did the agenda meshing in the previous session. So I will move on. And now let's start with our first presenter, Christian, who is on site. Christian, please welcome.
Okay, hello everybody. This is Christian Schmutzer. I'm standing here as a representative for all the authors and the contributors of this draft. And I'm going to introduce circuit style segment routing policies. So next slide, please. So what are we trying to achieve with this informational draft? We essentially want to enable service providers to build one segment routing network that can not only run typical connection, what I call connectionless services like IP or VPN connectivity or layer 2 VPN connectivity, but also address the requirements and the needs for what often is called private line, which is essentially a connection-oriented point-to-point transport. This could be legacy TDM connections, but it also could be Ethernet layer 2 VPN point-to-point services with strict bandwidth guarantees. Those services generally have a set of requirements which are different to the traffic that you normally run to carry, internet traffic or connectionless traffic. Generally, traffic engineered paths in a persistence manner are required. strict bandwidth commitment, because this is generally delivered by TDM switch networks like Sonnet SDH or OTN. And then with that comes also the requirement for end-to-end path protection, because that allows you to have end-to-end bandwidth commitment for not only the working, but also the protect path, and switch over your traffic in less than 50 milliseconds. And last but not least, OEM or path integrity for the engineered paths is a requirement that has to be addressed. Next slide. So what are the characteristics of segment routing circuit style policies? Essentially, we are taking two SR policies, one in the forward and one in the reverse direction, and we are bundling together those two policies in a bidirectional association. What also comes here in play is that for those SR policies, we request a bandwidth to be administrated and committed. We also want the path in the forward and the reverse direction routed along the same path through the network. So co-routing is indicated as a requirement and a characteristic. In order to make the path deterministic, we actually enforce that the segment lists used for those SR policies are supposed to be a list of strict hops with unprotected adjacency sits. And I will come to the point about the unprotected adjacency sits in a second. Also, because in these environments for those services, generally the path should never change up until an operator would request a change. No path reoptimization shall be applied to those segment lists. For protection, in particular end-to-end path protection or restoration, we use multiple candidate paths to build the recovery schemes I will talk in a second. And because we're using end-to-end path protection, no local LFA-like protection is supposed to happen, and that's why the segment lists shall be constructed using unprotected adjacency sits. In order to observe the proper operation of each path, OEM using stamped protocol and loopback mode probes will be applied to perform liveness as well as performance measurement to understand the delay and the loss of each path. Next slide, please. So what are we proposing here in this informational draft? It's not any extensions, but really a summary of already defined mechanisms or constructs to be grouped together in order to form a solution. The network is expected to be configured with unprotected adjacency sits on all the links. They could be manually configured to make them persistent across router reloads. They could also be allocated by the system. This is an implementation detail. IGB and BGP LS extensions would be used to disseminate the topology information so that the PCE used for the path computation is aware of those adjacency sits. With that also comes that for each and every link, we want to know what the available bandwidth is per link in that topology so that the requested bandwidth for the path delegation can be properly administered in the topology. The PCC, basically each endpoint of the pair of policies, will delegate the path computation to the PCE. It will use already existing mechanisms like the bandwidth object to request the bandwidth. And it will use the LSPA object by setting the L bit to 0 and the E bit to 1 to avoid that any local protection is going to be applied in the data plane. The bidirectional association object will be used with the C bit set to 1, so that co-routing will be honored in the PCE when doing the path computation. And if we want protection and recovery, which I will detail in the next slide, we're going to use the SR policy association to associate multiple candidate paths with a particular policy. Oops. Did we drop or?
Yeah. Yeah, he's back.
Was a drop at my side. I'm back. Let me go back to the slide that you were presenting.
I guess this was a test with whether I remember what's in my slide. When we have multiple candidate paths, we're going to use disjoint association in order to have the path computation be done in a disjoint manner, which is particularly important for one-for-one protection. And then again, the strict hops and no re-optimization will be covered by Samuel in the following presentation. As you see with the footnotes, all these, let's say, semantics or mechanisms have already been defined in either existing RFCs or IETF drafts. Next slide. So one very important and, let's say, the more comprehensive aspect of circuit-style segment routing policies are the recovery schemes. Because of those connection-oriented networks generally giving all sorts of flexibility to operators to build recovery schemes, we want to honor those requirements and provide solutions. The most simple one is unprotected. So you have one candidate path from, let's say, A1 to Z1, and if that path would go down, it is expected that the traffic will not recover. But it is also expected that most real-time deployments will likely have another unprotected circuit-style policy between a node A2 and Z2, and they're going to be computed from a path perspective in a disjoint manner, and operators use those two unprotected policies in, let's say, a redundant mated pair so that the service layer can handle the redundancy and the traffic recovery. On the top right, a slight variation of unprotected, which is 1 plus R, meaning you have one candidate path, and if that one fails, on demand, you're going to set up or establish another candidate path around the failure. That is on demand and not guaranteed, but still we are requesting bandwidth for that delegation. So the operator has the opportunity to recover the traffic if a failure happens, not in less than 50 milliseconds, but at an acceptable time to overall provide good high availability. For strict 50 millisecond protection, the one-for-one protection scheme would be used. This is the bottom left. You have two candidate paths, again with two preferences. The higher preference path will be active. If that one fails, the second one will be activated. Both will be pre-programmed to accomplish sub 50 millisecond protection, and computation again is disjoint. And last but not least, the most complicated but most versatile approach is to have one-for-one plus R protection, meaning it's the slight variation of the previous one, but if both the working and the protect fail, you're going to have a third candidate path that will be on demand established and try to recover the traffic even in a more severe network degradation. The state of the candidate paths will be indicated by the O flag in the LSP object with the existing semantics of 2 meaning active, 1 up, and 0 meaning down. Next slide. This is all I had to share. We appreciate your comments and discussion, and we hope that this introduction was interesting.
I see Haomian in the queue. Haomian, go ahead.
Yeah, Hamia from Huawei. So actually, I'm trying to understand one question for clarification about the term used for the circuit style, because I'm coming from the circuit side. So are you trying to approximately following the kind of bandwidth guarantee mechanism in the circuit style only, or you are referring to any additional features? Because given the network as packet switching hardware, it is hard to how to say it's hard to achieve the circuit style characteristics.
Yeah, so maybe one thing that I may not have clearly mentioned. So what I indicated before is that for each and every link in the topology, we allocate a bandwidth to the path computation element, right? And what the assumption here is that in the segment routing network, only circuit style segment routing policies have strict bandwidth guarantees, and those guarantees will be call it mission controlled against the bandwidth that you have on a per link basis. Any other traffic will not have a strict bandwidth guarantee, and for that matter also be mapped to diff-serve queues in the links at a lower priority. So only what gets a strict bandwidth guarantee will have the highest priority and will get a strict commitment. Anything else will be lower priority and hence not have a strict bandwidth guarantee.
Okay, thank you. The point, I get your point, but the personal suggestion would be try to change the current term circuit style into something like bandwidth guarantee or something similar.
Okay, so it was more about the name rather than the concept and the behavior. Okay, got that, yes.
John, go ahead.
Thanks, John Scudder, as an individual. I'm just curious about, you spoke a couple times about 50 millisecond restoration. And if we look at your, maybe it's the next slide with the A and the Z, or well, yeah, that one. So in your one-for-one, presumably you can't guarantee 50 millisecond unless you have, unless you bound the latency between A and Z, right? If you're excluding any kind of midpoint protection, because all the protection has to be engaged from the head end.
Yes, I mean I guess the well-known latency and notification aspect of very long paths would be applied. So maybe in that sense, my goal for sub 50 milliseconds was not 100% appropriate. I guess the notion is that both paths should be established, operational in the data plane, and once liveness detects a problem, you switch over to the second path immediately.
Okay, so this is like the colloquial use of 50 milliseconds to mean as fast as possible.
Yes, I think that would be a fair statement, yes.
Okay, thank you.
Tariq, go ahead.
Saad with Juniper. My question is there an assumption that there is one PCE managing only SR paths in the network? And is it only one PCE in the network? Or there will be multiple, or can be multiple?
Yeah, that's a quite complex question. I would say in the most simple consideration, it would be one PCE responsible for placing SR policies that have strict bandwidth guarantees. Of course, someone could consider multiple PCEs somehow collaborating, but the problem then appears is how to get a consistent view of what has been already admitted in terms of bandwidth guarantee and what not, and to avoid race conditions. But I would say from a concept perspective, circuit style segment routing policies are somewhat independent from the, let's say, PC architecture, if you will.
If there is an assumption, then please make it in the document. Thanks.
Okay. Yeah.
Actually, there is the state synchronization draft, which does talk about this. There is a working group draft that we have, PC state sync. So have a look where this kind of problem is being discussed, where multiple PC collaborate and exchange the bandwidth information. Yeah, Fan Yang, go ahead. You're next in queue. Fan, we are not getting any audio from you. Cheng, can you go ahead instead while Fan figure out the audio issue?
Have done such of things in CMCC 2 or 3 years ago by using pod segment, and I think it would be a good chance to work together with pod segment and this draft. I think I need to read more about the draft, and yeah, that's it. Thank you.
Fan, are you able to speak? Maybe use the chat window instead. And I also have one comment here. My first comment would be at the very high level that if we are defining something like circuit style SR policy or whatever we name it later on, where this could be not just signaled in PSEP, but in future there could be a use of this being signaled in BGP as well. So first, my question would be, is it really PCEP specific, or is this a generic work that later on can use signaling in BGP, even YANG or something? And if it does, then maybe we need to find Spring as a better home for the overall idea of this circuit style SR policy. And only maybe the next document what we have, which is the PCEP extension, that could focus on PCE work. So my question to authors would be that, is this really PCEP specific?
I don't think it's necessarily 100% PCEP specific, but for more, I'm pretty new to IETF, so I can't, properly answer your question, I think. But I think what you're saying is something that definitely can be considered and is making sense to me.
Yeah, and also one thing which stuck me a little, we are saying that we don't want PC to do recomputation here. Then the idea of why delegate, why give control to PCE when we actually don't want PC to recompute paths, that was not very clear to me. Maybe we should do stateless then, and like just ask PC to give us the path, and no need to delegate the path to PC. So this part also was not clear. Maybe either you want to answer now, that's fine. Otherwise, we can take this to the list as well.
Yeah, I probably can't answer the stateless versus stateful per se, but I think what I can tell you from my interactions with operators is that in the transport world, people like to have, let's say, a computation done by a controller or a system and don't want to deal with it manually. But once it was chosen, it should be staying the same, and that's where the requirement is coming from.
So I think there is no advantage of active stateful PC we are getting in that case. Anyway, let's not take up more time. We should discuss this in mailing list. So I request you to start a thread and let's have more discussion on the list.
Thank you.
Thank you. Okay, next we have Samuel.
Hi all, I'm Samuel Sider from Cisco. I'll be presenting draft about PCEP extensions for circuit style on behalf of authors. It's new draft, so it was not presented before. Next slide, please. Draft contains PCEP extensions needed to satisfy requirements of connection-oriented transport services using SR policies, also called circuit style SR policies. Christian, in his presentation, already described those requirements like path persistency, hop-by-hop behavior, strict bandwidth guarantee, and end-to-end protection. And he also described circuit style SR policies in general. So I will not repeat that part. I'll just describe only PCEP extensions which are needed on top of existing RFCs. Next slide, please. This draft contains two parts. First one is introducing ability to request strict path, so path consisting only from strict hops for specific LSP. For SR, that means the usage of adjacency seats only. For stateful messages, new flag was introduced. And for stateless messages, just clarification of existing flag for segment routing was done. Because flag was introduced in one of initial PCEP RFCs and no clarification was done as part of RFC with SR extensions. Second part is about adding ability to control path computation triggers. So operator on PCC can explicitly control path computation triggers. For example, if path computation should be, or if path should be recomputed in case of topology change or in case of any periodic trigger. Next slide, please. As mentioned before, in stateless messages, there was already OFLAG in RP object, which was specifying if strict path is requested or loose path is acceptable as well in PC request message, but it was not explained what that means for SR. So we are adding the explicit statement now to clarify that in case of strict path, only adjacency seats must be used. For stateful messages, we are adding new flag in LSP extended flag TLV to cover a similar functionality. TLV is applicable to both SR and RSVP. In PC report message, flag is indicating if PCC requested strict path, and PC is supposed to reflect value of that flag in PC update message. So it will indicate if path computation was done considering strict path requirement or not. The name O flag was chosen just because the O flag was used in stateless messages as well, or in RP object. Next slide, please. The second part of the draft is about controlling PC path computation behavior from PCC side for specific LSP. For now, two flags were introduced, one for blocking path computation if topology used by PC for path computation was modified. Basically, if PC received any change, for example, from IGP or from VGPLS. Second is for blocking any periodic error optimizations. So we are open to introduce any other flags to cover other triggers if needed. Basically, the TLV is extensible, so if there are other triggers which can cause recomputation, then the TLV can be still extended. Purpose of this TLV is to decrease number of recomputations and path changes done for specific LSP, so to achieve path persistency. If no flag is set in the TLV or TLV is absent, then all path computation triggers are allowed, and it is just on PC, on the local policy of the PC to decide if path computation should be triggered or not. It is done that way for the future, so any new flag can be handled in backward compatible way. Next slide, please. So thanks for listening. Any comments, any questions are welcome. We have already received some feedback, so some updates to the draft will be done soon. Also, thanks Drew for your comments. We are discussing the proposal as well. I mean, the comments in the mail thread.
Tariq, go ahead.
Yes, hi, Tariq Saad with Juniper. My question, it seems that you want to lock the path after it's set up. You don't want it to change. So why not have one bit to say lock or pin down the path instead of multiple?
That can be definitely done. Here, we just wanted to clarify, or we wanted to introduce maybe something with higher granularity, but yeah, in this specific case or for CS specific policies, the one flag would be sufficient. So yeah, we can do that. It's just about the added value of two flags versus having just one flag. So both options are possible.
Andrew, go ahead.
Yeah, just kind of echoing a little bit what Tarek just said is I really do like the recomputation triggers TLV, but the idea of a bit for pin to path is kind of nice. But in that same token, I do like the flags that you have here. The only thing that I'll just kind of reiterate that I had mentioned in the chat was it wasn't quite clear to me that when it says about don't recompute due to updated topology information, let's say something happens in the network or there's uncontrolled traffic, right? So if we're trying to guarantee bandwidth for a given path, for a given candidate path, and maybe there's a traffic surge on, I don't know, legacy LDP traffic, or maybe a lag member dropped, which means the capacity dropped. Would one expect the PC to tear down the path because bandwidth is no longer met? Or should it still stay up and valid in that case?
So I would say that I can clarify it in the draft, but I would say that if LSP should be really down, then basically the trigger can be considered as the report with all flag indicating that the path is down, and based on that, PC can potentially still recompute. So even if LSP went down just because of the topology change, we can still PC can still trigger the path computation based on LSP going down. And because in case of CS policies, we have backup. So if primary path is going down, then backup can still take over. And primary path can be reported as down. PC can recompute it because it can see LSP reported with all flag set to down, and then again both candidate paths can be up. So maybe we can introduce one more flag here to indicate if PC can recompute if LSP is down, or if it can recompute if original path is still valid.
Yeah, I think the is still valid is the important part, because in this case, if there's a bandwidth invalidation in the network, the PCC wouldn't actually be aware of it because naturally there's no signaling. So if PC is doing, let's say, telemetry collection, it's only the PC that can actually say, hey, you know what, I'm sending your traffic flow across a link that doesn't support that capacity anymore. Unless, of course, you're doing packet loss detection or something as well. Yes, I like the idea of saying, you know, is path still valid? You know, you're permitted to do something as long as, you know, the path is no longer valid. I think would be a good kind of concept to introduce here.
Yep, and maybe really one more flag can be introduced to say to indicate if topology trigger can be still considered if original path will not be valid. Thanks, Andrew, for the feedback.
Cheng, go ahead.
I see the O bit in the RP object in RFC 54, 50, right? So can we reuse that bit, or do we have any reason to? Okay, I saw that existing.
Yeah, so
you're reusing
in case of stateless messages, we are reusing existing flag. So we are just explaining what that flag means for segment routing. Just for stateful messages, we are introducing new flag because RP object is not used in stateful messages.
Okay, get you.
Fan, go ahead.
Am I audible? I think
Yes.
Thomas
Yes.
correct. Okay. Just a clarification question. I actually also did to the previous draft, previous presentation. I see that the previous draft is the informational draft. So can I understand this CS policy is this is based on the SR policy, but there's no extension there's no extension to the SR policy. Maybe this question is not for you, but for the previous presenter. But I see. Am I correct to understand this, that the CS policy is not extended by controlling protocol in terms of controlling control protocol compared to SR policy? And I understand that the PCE protocol extensions to the SR policy actually is not extended and is inherited as is inherited untouched to this CS policy.
Yeah, so the extension itself is, or the CS policies are basically implemented using existing RFCs. There are just these few smaller changes which are done, which are needed in PSEP. But from SR policy perspective, we are using existing concepts, and I'm not sure, Christian, do you want to add anything on top of that? I can see that we are standing.
Yeah. Can you hear me?
Yeah, just
Christian, do state your name.
Yeah, this is Christian. So thanks for the question. Yes, the circuit style SR policy draft is informational because we are not changing the SR policy architecture, right? So we are using existing constructs, like you have one candidate path or multiple candidate paths. You could have OAM or liveness on the candidate paths and things of that nature. Circuit style SR policies are really let's say, a description of using many different mechanisms that are based upon this policy architecture, as well as already defined PSAP extensions. And Samuel's extension is extensions that haven't been defined so far, but are also needed to overall make circuit style policies possible.
Yeah, thank you. I understand. One last question. If this CS policy actually is target to both SRv6 and SRMPRs, right?
That is correct.
Okay. Thank you. And this work is actually is very interesting. Bring very it's very interesting work, and it provides a approach to carry this the legacy services. But I think there are more considerations or more questions we can confirm in other working groups. It's not so PCE related.
Yes, and
Thank you.
definitely. Yes, we didn't have a lot of time, but I think we can have discussion on the mailing list. Like some of the DiffServ assumptions I didn't really cover in detail, but we can discuss this definitely.
Just one
Thank
point. Just one point that I wanted to also bring when I was discussing this with Samuel. My initial reaction of looking at this TLV felt very much like, oh, it's a policy, and we have policy association, and maybe we can just reuse it. But his reply was, and based on what I'm hearing in the room as well, people would like not to use generic policy association where you need to configure this as a policy, but rather have a sort of like a way to signal this well-known policies as a TLV outside. But I want the working group to think about it a little bit, that if we have this kind of well-known policies, what is the best way for us to signal in long terms? Do we define TLVs like this, or should we come up with a way of defining well-known policies that can and still use our policy association mechanism? So something to think about, and I would also be interested in feedback from the authors as well as others in the working group on it. Okay, and I think let's take that to the mailing list, and let's move to the next presentation. You have the floor.
Yep. Can you hear me?
Clear.
Hello, experts. I'm Yue from China Telecom. I will introduce our draft and some essential updates. Next slide, please. Well, considering the large-scale development of the Ethernet interface, it is possible to use the info contained in the layer 2 frame to simplify the end-to-end packet forwarding procedure. Based on RFC 9050, which specifies the PCAP extensions for PCCC to derive an MPI's label switch path. This document defines the PCAP extension for VLAN basis traffic forwarding in native IP network. Compare with the RFC 8821, which describes an architecture for PCE-based traffic engineering in native IP networks. This draft describes the processes of data packet forwarding system based on VLAN info. Okay, next slide, please. There are strong motivations for the operator to provide the end-to-end solution to preferred application traffic. So this page shows the target scenario of this draft. The requirement should meet the following 2 points. The first one, intro or inter-domain traffic guarantee. The second one, the controller senses the network states and dynamically adapt to the network states. Okay, next slide, please. Based on the scenario above, the architecture requirements can be generalized as follows, which are consistent with our FC 8821. The first one, same solution for native IPv4 or IPv6 traffic. The second one, support for intra or inter-domain scenarios. The third point, achieve end-to-end traffic assurance with determined queues behavior for traffic requiring a service assurance. The fourth one, based on the centralized control through a distributed network control plane. The fifth one, ability to adjust the optimal path dynamically upon the changes of network states. No need for reserving resources for physical links in advance. Okay, next slide, please. As shown in this figure, the procedures for VLAN-based traffic forwarding are as follows. Step 1, the PC calculates the explicit route and sends the route information to the PCCs through the PC initiate messages. Step 2, the ingress PCC, like R3, forms the VLAN forwarding routing table, and the transit PCC, like R1, R2, and R4, and the egress PCC, like R5, forms the VLAN crossing routing table. Step 3, the packet to be guaranteed matches the table and then be labeled with corresponding VLAN tag as marked in the red line. Step 4, the labeled packet will be further sent to the PCC's specific sub-interface and identified by the VLAN tag and then be forwarded. Next slide, please. The data packet encapsulation processes is shown in these slides. When the original data packet was sent to the ingress node, it will look up the VFR table of R1. If matched, the packet will be labeled with corresponding VLAN tag. The labeled packet will be sent to the transit node. Similarly, it will look up the VCR table, which only contains the in and out VLAN, and then be forwarded to the ingress node. The out VLAN of the VCR table is 0, so the VLAN will be unlabeled and returns to the normal forwarding. There are potential conflicts in future when each kind of service expands. So compared with MPLS, the mechanism uses a completely new address space to bypass the already used MPLS label space, which will not conflict with other existing protocols and avoid considering the label overlap of the already used MPLS services in the MPLS native IP mixed environment. Compared with SRv6, it avoids the SRH overhead problem. So totally, it is suitable for IPv4 and IPv6 networks and can leverage the existing PCE technologies as much as possible. Next slide, please. And we specify the VLAN forwarding and VLAN crossing routing table like the figure shown in these slides. VLAN forwarding routing table should be maintained in the ingress PCC and is used to match the packet to the guaranteed base to be guaranteed based on the source and destination BGP prefix. VLAN crossing routing table should be maintained in the transit PCC and the egress PCC. Through the mapping of the in and the out VLAN, the data to be guaranteed will be transferred to the specific interface and be switched on the out VLAN for the transit PCC or 0 for the egress PCC. Next slide, please. Based on the last version, we also added the VLAN switching path sequence diagram to describe the VSP setup operation. Refers to our RFC 8281 and RFC 9050. Next slide, please. Okay, that's the main content of this draft, and the comments and the suggestion has been fully discussed on the mailing list and have been resolved. So I think this document is ready to request for adoption. Thank you.
Are there any comments from anyone? One comment which I would also ask is which I kind of alluded to during the last time when this was discussed as well. But the thing is, like when we did the native IP work in PCE, we had the document in T's working group, and it's already an RFC, and there was a consensus behind that approach. And for PCE to add an extension, it was pretty straightforward. In this case, what we are doing is we are introducing things like VFR, VCR, and a sort of tables which needs to be in the data plane. And I am a little bit uncomfortable with it because it's sort of like outside what PC working group is chartered to do. And I wanted to get an explanation, or if I remember, the explanation I was given is this is not something which is new. We are just defining new terms here. And I was still not sure, and I wanted to get a feedback from the working group as well on whether they consider this as a part of PCE, or whether uh, this idea of how this VFR tables and VCR tables needs to be described in some other place, and then the extension should be done here. So any feedback from the working group would also be nice, as well as from the authors on this.
Yep, we have discussed with the cooperators, and I think we have discussed already. And we made some updates on the newly discussed draft, and maybe we can discuss further in the mailing list.
Sure. Arjun, go ahead.
Hello?
Yes, we can hear you.
Yeah. I think the VCR table is implemented in the device. So here the main point is instruction sent from the PCE to the PCC. So I think such work should be included in the PCE working group. Okay.
So let's just to clarify, what I meant was that anything related to our message, definitely it's a part of PCE, but the document also describe how this forwarding is happening, and how the VFR tables are populated and how they are maintained. Is that a part of PC charter? I'm not sure, and I will take this up with our AD and discuss with Julian as well, and we are looking for feedback from the working group as well. So please let us know what feedback that they have about this document.
Okay, I think we can treat the table as a special policy, traffic policy. So it is using the existing mechanism. Okay.
Okay, let's continue that discussion. Let's move on to the next presentation. Yunan, go ahead.
Can you hear me?
Yes.
Okay. Hi, PCE experts. I am Huanan Li from China Telecom. In the last version of our documents, we described the related processes of peer multicaster based on PCE. Next slide, please. In this update, we want to use a PCE-based document to include the management processes of IP, MLDP, and SR multicast trees. The same idea based on BGP has already been accepted. The overall process includes three aspects. The first is multicast tree information discovery. When a PCE calculates a multicast tree, it needs to collect tree information of roots and leaves. We have designed corresponding signaling to support this. The second is multicast tree state setup and updates. This process is to set up per tree forwarding states on relevant nodes for different multicast trees and the replication technologies, and establish relationship between multicast tree and P2 and P paths. The third is multicast statistics synchronization. This process is to synchronize multicast statistics between egress and PCE and between PCE and ingress for multicast service analysis and business development. Next slide, please. In the multicast tree information discovery process, ingress sends a source registration to PCE, where report message carrying multicast source registration objects. The sent message needs to carry tree identifier to used to identify a specific multicast tree and the information of source. In this message, the D flag needs to be set to request the PCE to calculate the P2MP path for ingress. PCE will respond with a message confirming the request. The egress is the multicast receiver joining or leaving requests to PCE where report message carrying multicast receiver information objects. The send messages need to carry tree identifier of the multicast tree that egress is requested to join or leave, and the VPN of receivers, and selectively carry BFR information of egress in bare multicast scenario. For different multicast trees, the tree identifier is different. For IP multicast, it is SG or StarG tuple. For MLDP multicast, it is MLDP FAC. For SR multicast, it is root tree ID tuple. Next slide, please. For the process of multicast trees state setup and updates, there are different processes for different forwarding technologies. For labeled trees, the process has been defined and introduced in document PCEP extension for P2MP SR policy, different from P2MP path. In some cases, each related nodes need to be assigned a per-tree label to identify the multicast tree. In VPN scenario, it is also necessary to assign VPN forwarding identifier. Therefore, we define the tree label static TLV and VPN forwarding identifier TLV. These two TLVs needs to be included in CCI objects in this process. In addition, the LSP object needs to carry tree identifier to associate multicast tree and the P2MP path. Next slide, please.
You have 1 minute.
Okay. For beer tree, firstly, it's a PCE combine BFR information of egresses into bit string. Then PCE sends VPN forwarding identifier to egress via update message, informing them to forward. Finally, PCE sends bit string and VPN forwarding identifier to the ingress via tree forwarding state synchronization object to inform ingress to encapsulate and forward packets accordingly. Depending on whether to create or update a beer tree, the initiate message and update message are selectively used. In this message, the LSP object needs to carry IP tree identifier to associate tree identifier and bit strings. Due to time constraints, multicast static test synchronization will not be described for the time being. We can discuss it later. That's the main content of our document. Any comment on our work are welcomed. Thank you.
Thank you. Please pass the comments on the list, and let's welcome our last speaker. Thank you.
Hello, can you hear me?
Yes, Ran, go ahead.
Okay, thank you. Hi, hello everyone. I'm Ran. I'm going to introduce PCEP procedures and protocol existence for using PCE as a PCE-CC of beer. Next, please. For next is the introduction. This draft specifies a new mechanism where PCE allocates the beer information centrally and uses PCEP to distribute them to all nodes. Then PCC generates a bit index forwarding tables. There are two ways in our draft to generate a bit index forwarding table. The first is the PCE-CC allocate parameters, for example, beer subdomain ID, BFR ID, beer algorithm, and IGP algorithm carried by CCI object. And the parameters, for example, BFR prefix, BSL, encapsulation type, BIFT ID, and max SI carried by beer encapsulation TLV, and BFR prefix carried by FEC object to the PCC. On receiving the beer information allocations, each PCC uses IGP protocol to distribute beer-related information to other nodes. The node calculates the next hop. In this case, each PCC only needs to allocate its own beer information by the PCE-CC. Another is in scenario where the IGP protocol is not used or available. Each PCC is allocated its own and neighbor beer information by the PCE-CC. Then PCC generates a bit based on the information received. The beer information include beer subdomain ID and BFR ID carried by CCI object, BFR prefix, BSL, and encapsulation type. BIFT ID and max SI carried by beer encapsulation TLV, BFR enable carried by address TLV, and BFR prefix carried by FEC object. Next, please. For this case, is talk about the protocol extensions. It includes a beer capability advertisement. We add B bit in capability sub TLV to extend beer capability, and we also define a new pass setup type for beer TE. For CCI object, we define a new CCI object type for beer and defines or reuses two optional TLV. One is beer encapsulation sub TLV to carry the beer encapsulation information, and the other is address TLV to carry the BFR out interface and next hop information. For FEC object, we reuse FEC object 1 and FEC object 2, which is defined in RFC 8664 to carry the BFR prefix. Next, please. Next is the extension details. This is for PCE-CC capability sub TLV. A new, just like the picture, the format. We defined a new bit. This is a B bit. In capability PCE-CC capability sub TLV. If it said to 1 by a PCEP speaker, it indicates that the PCEP speaker is capable for PCE-CC beer capability, and PCE would allocate beer information on this session. Next, please. Next is a new pass statement type is defined. Next, please. Next is CCI object. We defined a new object type for beer purpose. It includes subdomain ID, beer algorithm, IGP algorithm, BFR ID, and optional TLV. Next, please. We defined two optional TLV. The one is beer encapsulation sub TLV. It includes the ET flag, which identifies MPS encapsulation of non-MPS encapsulation. And it also includes max SI, local bit length, and BIFT ID. Next, please. Next is the address TLV. We reuse address TLV to carry the beer out of the interface and next hop information. Next, please. As we know, beer information is always associated with a host prefix, so we reuse FEC object 1 and object 2 to carry the BFR prefix. Next, please. Next step is comments welcome. Thank you.
Any last comments? We have 30 seconds, not even 30 seconds, but we'll allow one last comment if anybody has. Okay, I think let's discuss this on the mailing list. Thanks for your work.
Okay, thank you.
Julian, would you like to close the meeting?
Yeah, sure. Thank you, Drav. So thank you everyone for attending the meeting. We certainly hope that we will be able to meet face-to-face next time. Hopefully, finger crossed. So talk to you soon. I hope, and enjoy the IETF week. Thank you, everyone.
Thank you, everyone. Thanks, Hari, for taking minutes as well as being our person on the ground. Thank you. Bye.
Bye, Harry.